What is up, guys? We're going to be taking a look at this lab, blind SQL injection with time delays and information retrieval. In the previous Portswigger SQL injection lab, we were introduced to the concept of time delays. We're not going to revisit the syntax for that, so if you're interested in checking out how timing attacks work in SQL injection, check out the previous lab. We are now going to be seeing how we can use the timing delay vulnerability to retrieve information from the database. We're given some information. The database contains a different table called users with columns called username and password. You need to exploit the blind SQL injection vulnerability to find out the password of the administrator user. So this is a type of blind SQL injection attack, but it's specifically a timing-based blind SQL injection attack. All right, without further ado, let's fire up the lab. So here's a look at the main page in the lab. We're assigned a trackingID cookie. Here's a copy of our latest HTTP request sent to the server. You can see our cookie trackingID, and we're going to inject into the trackingID value. So over on the right-hand side, let's have a look at request cookies, and we're going to edit the value of the trackingID. Now, we don't care too much about the existing cookie, so we're just going to replace that with X. We are going to inject a single quote. And in this case, it's possible to completely end the SQL query with a semicolon and start a new SQL query. So that's what we're going to do in this case. Things won't always be this convenient, but the purpose of this lab is to illustrate the concept, so it serves pretty well for that purpose. So let's start a new SQL query. The objective here is to provoke a conditional response from the database. We have the ability to make the database do two different things. We won't get any visual output from the web page itself, but we can get the database to sleep for a specified period of time, and we can also get the database to not sleep. In other words, we'll get an instant response from the server. The question is, how can we manipulate that behavior into generating true or false responses from the server? Well, here's how. In postgreSQL, we're going to make use of case. Now, if you're familiar with regular programming languages, case is very similar to if-then. So case is like if. So we say case when. So if, and let's input 1 equals 1. This is something that we know is always going to be true. But inside those parentheses, we are going to replace with a subquery that can generate a true or false response. But for now, we'll just input something that clearly returns true. So if 1 equals 1, then, and we can make use of the PostgreSQL sleep syntax, pg_sleep 10, but then we can also select an else. So we have if 1 equals 1, then sleep, else, and we can choose pg sleep 0. So this means we're asking the database to not sleep. Else pg_sleep 0. Now the way the syntax works here is we have to end this conditional block with the term end. And in this case, we're simply going to comment out the rest of the query. So let's choose apply changes. And instead of 10, let's choose 3 seconds. So I'll click send. Notice we get a 3-second delay. Then we get a response from the server. So the SQL database evaluated 1 equals 1, saw that it was true, then executed pg_sleep 3 seconds. If we change the value of the parentheses to something that returns false, then the else block is going to be executed. Let's click apply changes. If I choose send, you can see we get an instant response from the server. If I change it back to 1 equals 1, click apply changes, click send. Once again, we get a 3-second delay while the database sleeps. Now is when we can start making use of subqueries inside the parentheses. So if the parentheses contain something that is true, then the database is going to sleep. Whereas if it's not true, then the database is not going to sleep. So what type of subquery could we include here? Username equals administrator. Now this is actually going to be selected from a specific table. That's something that needs to occur after the if else or case then block. So we can choose end from users. So in this case, the SQL database is going to search through the users table. And of course, this is all happening very quickly. It can traverse the entire table in a matter of milliseconds, especially when the table is small. However, if at any point the information in brackets username equals administrator evaluates to true, then the database is going to sleep for 3 seconds. So if we have a 3-second delay, it must mean that there is a row in the users table where username equals administrator. Okay, let's click send. we get a 3-second delay. It means that there is a user in the table with the username administrator. Now, this is where it starts to become a regular blind SQL injection attack. We have the ability to elicit true or false responses from the underlying database, and we can start asking a wide range of very granular questions. For example, if we modify this, when username equals administrator and length, so this looks at the length of a string, length of the password field is larger than 1. So it's now specifically looking for a row in the users table where the username equals administrator and the length of the password field is larger than 1. Click apply changes. Let's click send. We get the 3-second response. Whereas if we choose something like larger than 30, click apply changes, then click send, we get an instant response from the server. So we know that the password of the administrator user account is not larger than 30 characters, but it is larger than 1 character. This is where we can make use of Burp Intruder to enumerate the number of characters in the password. Now, you could, of course, do this manually. We've tried the values 1 and 30. You could try all of the values in between to find the number of characters in the password. But the slightly more sophisticated way of doing this is making use of Burp Intruder. So if I right click on the request, choose send to intruder and head to the intruder tab, we can then place some payload markers around the length of the password. So we have this %3e, so that is the URL encoded greater than. It's this integer here before the closing right bracket where we want to insert payload markers. So we are highlighting that. We're then choosing the add payload markers button. We can see either side of that integer get a payload marker. Attack type sniper basically means we have a single field and we're going to try a range of values. Let's now head to the payloads tab. Payload type, we're going to choose numbers from 0 to 30 step 1. Okay, in the top right, let's choose start attack. It's basically going to resend that request, trying all the different values. Is the password larger than 1? Is it larger than 2? Is it larger than 3? In the response column, we see the length of time taken for the server to respond in milliseconds. So 3000 is 3 seconds, and we can see we're trying all of these values and we are getting round about 3000 milliseconds. That means the database is sleeping for all of those values. Now, just returning to the intruder tab temporarily, it may be obvious that this is not the most efficient way of doing things because every time we get a true response from the server, we have to wait 3 seconds. And it's clear that the password is longer than 10 characters from what we've seen so far. So we can optimize this simply by changing the greater than sign to smaller than. So we're getting a bunch of false responses, which are associated with PG sleep 0. Then when we get a true response, then the database will sleep. So it's going to be a bit faster this way. So %3e is greater than. If we just head to the decoder, we can see greater than %3e, less than %3c. So heading back to intruder, let's change %3e to %3c. Let's keep everything else the same. Let's choose start attack. And we'll see now it should go very fast through these HTTP requests because the database is not sleeping. Eventually we'll hit a point when the database sleeps. That's because we're getting a true response from the server. We can see with the payload 21, we get a response time of 3028 milliseconds. In other words, to translate this into English, we asked the database, is the password of the administrator account less than 20 characters? No, that is false. Is the password on the administrator account less than 21 characters? Yes, it is. So if it's not less than 20, but it is less than 21, we've enumerated the exact length of the password on the administrator account. It's 20 characters. Now we know the length of the password. Returning back to the repeater tab, we can begin to enumerate the exact characters in the password itself. And since we can only extract true and false responses, it's fairly equivalent to asking the database, is the first character of the password A, true or false? Okay, it's not. Is the first character of the password B? Is the first character of the password C? We ask every single possible letter or number until we get a true response from the database. We've then enumerated that specific part of the password. So let's see how the syntax for that looks. We need to make use of substring in this case. Substring is a piece of syntax that has slightly different syntax in Oracle, but is actually identical for MySQL, postgreSQL, and Microsoft. So we're going to be making use of substring. The idea is we pass the string itself. That can be the result of a query. We are going to specify the position in the string and also how many characters from the string. So that last value is always going to be 1 for us because we're going to enumerate this 1 character at a time. We're going to start with position 1, we're going to move to position 2, etc. Select case when username equals administrator, and we can get rid of this length information for the password. We're now going to say and substring, so we can use the value password. So this is going to be the extracted value from the SQL query, from the row in the database, the password column. We're interested in position 1, and we're interested in a string length of 1, and substring password 11 equals A. So it's a string, we should wrap that in single quotes, and then we are going to close this subquery section. So select case when username equals administrator and substring password 11 equals A, then PG sleep 3. In other words, if the first character in the password is A, the database will sleep for 3 seconds. If not, it's not going to sleep. Let's choose apply changes. Let's send that to the back end. We get an instant response that tells us the first character in the password is not A. Then the idea is to brute force this. We change it to B. Is the first character in the password string B? No, it's not. We get an instant response. Once again, the most elegant way of achieving this is making use of the intruder tab. So let's once again send this request to the intruder. This time, let's wrap payload markers around the B. And we're going to try all of the payloads from A to Z and 0 to 9. Let's head to the payloads tab. Now, I believe with the pro version, you can simply access this drop-down box, add from list, and you can choose A to Z, 0 to 9. Unfortunately, if you have the community edition, there's no functionality for that, even though it's fairly basic functionality. We can add these manually. It won't really take too long. Basically, just need to type out the alphabet. There may be a better way of doing this. I'm not aware of what it is. So now we have all of the characters, A to Z, 0 to 9, and we can choose start attack. You see it's going through, it's trying all of the different letters as the first letter of the password. And you can see for character H, we get a response time of around about 3 seconds, indicating that the first value or the first letter in the password is H. Now, here is where we run into the limitations of the community edition. It's not that practical to solve this lab using the community edition of Burp Suite. It is possible, it's just not practical. And the reason why it's not practical is because if we want to enumerate the entire password, we're going to find ourselves being throttled. Intruder attacks are throttled. Now, when we're just enumerating a single character, it's really not that painful. We've made 36 requests. It's finished in under a minute. And what we could do is run the same attack for all 20 characters in the password string. So we know that the first character in the password is H. We can simply head back to the positions tab, and we can change the value in the substring function to position 2. So after %20, we can change this to 2, and we can then enumerate the second value in the password string. So now we find the second character in the password is 9. If you want to fire up a WordPad document and enumerate every single character one by one for all 20 characters in the password field, that is fine. You will solve the lab that way, but it's not especially elegant. It's not really the hacker way. Now, the ideal way of doing this is making use of a more sophisticated intruder attack. Let's take a quick look at how that works. So now we can make use of a second set of payload markers. So we have payload markers around the character in the password itself. Then we can also add a second set of payload markers around the position in the string itself, which is the 2 here. Add payload markers. We change the attack type from sniper to cluster bomb. We head to payloads. Payload set 1 is the position in the string. So for payload type, we can choose numbers from 0 to, we know that there are 20 characters, step 1, that's our payloads for the first payload marker. Then we can head to payload set 2. Once again, doesn't make me feel good. We can brute force A to Z, 0 to 9, one at a time. Okay, so payload set 1, position in the string from 1 to 20. Payload set 2, all of the alphanumeric characters. Let's choose start attack. So we can see that the way this is working is it's trying the string A against all of the positions in the password. It then tries the string B against all of the positions in the password. You can see that this is going to result in 756 individual HTTP requests. And although we start off fairly quickly, things start to really slow down dramatically. That's because our intruder attack gets throttled by Burp Suite Community Edition because it's not the Pro Edition. This attack, I don't know how long it's going to take, and I don't really want to find out. I'm guessing when things start to really slow down, this could take over an hour. So although there's less work involved in enumerating the password string, it is a lot slower compared to running each character individually. We've seen that each individual character, we can enumerate that in less than a minute. So it'd probably take you about 20 minutes to get the entire password string. You can do things this way. It's a lot less work because we've set up the intrusion attack more effectively, but we're going to start getting throttled really hard pretty soon. This is going to take a long time. I don't really think this is worth it. Now, if you do have the Burp Suite Pro Edition, this is the best way of doing things. You are going to chew through those 756 HTTP requests probably in a matter of minutes. And what you'd be left with is the password string itself. The idea is that we can sort by response time. So at the moment, you can see we have 2 responses that took 3 seconds. So we know that position 14 in the password string is character B. Position 18 in the password string is also character B. You can enumerate the entire password that way. We're not going to do that because I don't want to waste time and I don't have the Pro Edition right now of Burp. So what are we going to do? We're going to use SQLmap. So over on the left, we have Kali Linux. This is actually running under the Windows subsystem for Linux. Very cool way of making use of Linux apps. So this is actually Kali running on Windows. First thing we're going to do is grab the URL of the lab. And by the way, if you don't have this installed, you can simply make use of the command sudo apt-get SQLmap. Now I already have it installed. If I type SQLmap, you can see we get SQLmap output. So we want to make use of the command SQLmap -u. This is to specify a URL, which we are going to provide inside double quotes. If we head to the edit menu here, we can actually paste the URL. Now it's fairly important that we direct SQLmap towards the idea that we are looking to inject into the cookie value itself, because by default, it's often going to look for a parameter within the URL itself. So if we just provide this command, it's basically going to get back to us and say, well, there isn't actually any injectable parameters in this URL that we can see. So we need to specify a cookie value, and we need to just lead SQLmap into making sure it tests the value of the cookie itself. So we can specify --cookie equals, then we can provide the cookie string. So something along the lines of trackingID equals X. In order to get SQLmap to try and inject into the cookie itself, there's a few things that we can do. One of them is simply to specify the level of the attack. So if we choose level equals 3, as part of a level 3 attack, it will make attempts to inject into that trackingID cookie. All right, without further ado, let's run the command. Testing if cookie parameter trackingID is dynamic. Do you want to URL encode cookie values? Choose yes for that. It's then going to run through a whole range of tests. It's really quite intensive, but it's still going to get done before that throttled intrusion attack that's taking place in the background through Burp Suite Community Edition. Cookie parameter trackingID appears to be injectable. It looks like the backend is postgreSQL. It is. Do you want to skip test payloads specific for other DBMSs? The answer is yes. We know it's postgreSQL. We don't need to be trying MySQL specific payloads or Oracle specific payloads. We know it's postgreSQL. For the remaining tests, you want to include all tests of PostgreSQL, extending provided level 3 and risk 1 values. Let's just choose yes. In other words, it's going to hit it with everything, no matter the level or the risk. Might not be necessary. We don't know. The only reason why you'd be worried about maximizing those values out is if it's in a production environment, you didn't want to knock a certain server offline, for example, or if you needed to be stealthy for whatever reason. None of that's true in this case. Pretty sure the Web Security Academy is going to be fairly resilient to this type of attack. It's basically designed for this type of attack. TrackingID is vulnerable. Do you want to keep testing the others? Not really. We know it's TrackingID that is vulnerable. So it's basically telling us it's vulnerable. We can see the payload being used, trackingID equals X semicolon select PG_sleep 5. Now we can select a new query for SQLmap. All we're going to do is tag --DBS on the end. So we're going to ask SQLmap to start enumerating the underlying database here. So it's now preparing a time-based attack. And just so you know, SQLmap builds off previous usages. So it's not like it's starting from fresh here. It already knows that it's vulnerable to a time-based SQL injection attack. Do you want to optimize values for DBMS delay responses? Yes. So we can now see that it's making use of blind SQL time-based injection to enumerate the name of the database. The name of the database is public in this case. We actually want to dig a bit further and start dumping the value from that database. So let's return to our original query. We're now going to make use of the -d. We know that the database is public, -t to dump a specific table, and we know that the table is called users in this case, --dump. Fetching column for table users in database public. We'll choose yes for encoding URL values. Do you want SQLmap to optimize values for DBMS delay responses? Yes. So we're now looking at a fairly similar attack to what's taking place in Burp Community Edition behind the scenes right now. The only difference is that we're not going to be throttled by SQLmap. So the current rate of attack is going to persist and be consistent throughout the entire attack. So you can see we are retrieving the column names for the users table. We have password and username. At this moment, we can see that a password field is being enumerated. And I believe the first row in the users table is very likely the administrator password. In other words, what we're seeing enumerated right now is the admin password. Just for a bit of fun, here is the intruder attack that's taking place in Burp Suite Community Edition. You can see out of 756 HTTP requests, we are now at 233. That thing is going to take a very long time, whereas we can see that SQLmap is really chewing through that admin password. And we can confirm that the responses match up. For example, if we have a look at character 3 in the password string, it's going to be G according to the intruder attack. Have a look at the third character that's being enumerated by SQLmap right now, it's G. So we're doing the same thing in SQLmap as is taking place in Burp Suite right now. We're just not being throttled by SQLmap. It's a lot faster. Now, the next thing that's being enumerated in SQLmap is going to be the username column of that first row in the users table. We know it's administrator. So we already have everything we need at this stage without having to wait for Burp Suite Community Edition. So let's log in making use of that password. So username is administrator, password. Username is administrator, we get the flag, congratulations, you solved the lab. If we leave SQLmap to run for a period of time, it is going to enumerate the entire database, and we've just asked it to dump the users table. If there are other tables in the database, it's possible to dump the output for those also. And you can see at this moment, it's already enumerating the password for another one of the users. We don't know the username yet for that user, but it is going to be enumerated next when it gets to the password column for the second row in the users table. So in summary, you have a few different options. If you have Burp Suite Professional Edition, use the two-pronged intrusion attack where we have two payload markers. It will enumerate fairly quickly, just like SQLmap. And you also won't need to worry about entering things like A to Z 0 to 9 manually. You'll have alphanumeric string in the drop-down box. Things are a lot more convenient if you have Burp Suite Pro. If you have Burp Suite Community Edition, you can either just wait for over an hour and accept the fact that you're being throttled. Alternatively, you can make use of single attacks to enumerate each character in the password. So you will have to set up 20 different attacks. It will be faster than the two-pronged attack, but it's obviously just a lot of work and it's still going to take you a good 20 plus minutes. Recommended option is just get familiar with SQLmap if you don't have Burp Suite Professional Edition. Fire up SQLmap, make use of the same queries that we've run here in SQLmap, and everything gets done for us that way as well. It's 100% fine to make use of SQLmap, but the reason why we didn't jump straight into using SQLmap is because we don't just want to be pointing and clicking tools at vulnerable apps. The idea is to understand how a time-based blind SQL injection attack works. That's why we went through the process first. We understand the concept behind how a time-based blind SQL injection attack works. Once we've understood that, only then have we fired up SQLmap just to finish off the work and extract the administrator password. All right, thanks very much for checking out the content. Hope it was helpful. Catch you guys in the next lab.